one light year. So one more time, 1 light year is equal to the distance traveled by light for 1 year. An example is if we are on Earth here, and let's say there is an explosion or any kind of accident that creates generate lights, and light is going to travel into space for almost forever. Now, after 1 year, this light is going to be traveled to a certain distance. This distance, this measurement, whatever that is called 1 light year. So 1 light year, even though it looks like it sounds like it's a unit of time, but it's actually a unit of distance for measuring distance between very, very far distance.
Mm-hmm.
Now, now that we understand what 1 light year is, we want to know how much that is actually, like in terms of something that we can understand. We understand meters, kilometers. If I tell you this is like 10,000 kilometers, you would kind of understand what it is. But if I tell you like 1 light year, still we don't know what that really is. So if we can have some sort of a conversion to kilometer or to meter that we as normal people can read and understand, that would be also a good idea. So let's try to do that.
Okay.
It was given to us that we have the speed of light. What's the speed of light?
3 times 10 to the power of 8 meters per second.
Exactly. So we know how fast light travels. So we know when the light was originally started to traveling from this point, it starts to travel with the velocity or speed of 3 times 10 to the power of 8. Just keep in mind, if you want to dig more into details of this scenario, there are actually a lot of research going
Mm-hmm.
on, even right now, speaking about is actually the speed of light 3 times 10 to the power of 8 all the time, even after it leaves the atmosphere and air, even when it enters to other like gravitational fields of other planets. So the speed of light may change during the time. So there are a lot of researchers and talks about how to exactly calculate it. But for the purpose of this stage and for the purpose of this course, we're going to assume the velocity or the speed of light is always 3 times 10 to the power of 8 into this space. So another thing that we need to calculate is 1 year is equal to how many seconds? So can you quickly convert that for us?
1 year.
Yes.
Uh,
So because our unit of velocity here is per second, meter per second, and I want to calculate how many meters the light will travel if it goes with that velocity, I need to know how many seconds are in a year. So you can, yeah, obviously use Google, or you can just like convert year to month, which is times 12, and then times 31 and count, or actually 365 days in a year, and then times 24 hours, then times 60 minutes, and then 60 seconds. So how much was that?
it was this. What's E? I never understood
E
this.
is 10 to the power of. Okay, so uh,
Oh,
if you exactly, you want to calculate it exactly, that you got 3.15
three, three.
times 10 to the power of 7
So,
seconds. Okay, very good. That's a very accurate number. If you calculate it with the different methods, for example, if you say in 1 year there are 12 months, and then 12 months there are number of days, and then you add it up, it's 365 days. Then you multiply by 24 hours, then you multiply by 60 minutes, and then you multiply by 60 seconds. Then you get very close to this number. So this is more accurate, 3.15 times 10 to the power of 7 seconds. So we know in 1 year, there are these many seconds, very large number. And we know that
Yeah.
the velocity of light is also very large. It's 3 times 10 to the power of 8. So that is like 300 million, 300 million meters, 300 million meters per second. So it means that if light starts to travel from this point, it can go 300 million meters away in 1 second. That's how fast it goes. So now if it's going with that velocity and it's going for that time, we can calculate the distance. The distance would be basically our delta D. We want to know how much this delta D is. We know the name of it. The name of it is called 1 light year. Now we're trying to calculate the measurement in terms of our own understanding. So delta D is equal to velocity times time. The
Okay.
distance that light travels is equal to its velocity times the time that it's traveling. So velocity is 3 times 10 to the power of 8 meters per second, and time is 3.15 times 10 to the power of 7. Okay, seconds. So that is going to give us something, a number, meters. That is the delta D. That is the measurement of our 1 light year. So let's quickly calculate that as well. Um, how do we do that? 3 times 3.15.
3 times.
9.45, correct? And 10 times to the power of 8 and 10 to the power of 7 is going to make it 10 to the power of 15 meters. So that is the one light year.
Mm-hmm.
Let's just call it 1 ly. 1 light year is equal to 9.45 times 10 to the power of 15 meters, which is
Yep.
also equal to 9.45 times 10 to the power of 13 kilometers. Okay, so this is the distance of the light year. Okay, just to quickly review everything and try to do one example. So 1 light year is our topic here, and we want to know how to calculate 1 light year, even though it sounds like it's a time measurement, it's a distance measurement, a distance that is traveled by light for 1 year. It's a very large distance, and it's only used by people who are trying to measure distance between planets and stars and working with space. Anything to do with traveling with the scale of speed of light. Now, if a light travels from Earth, from the green point on the left side, with the velocity of 3 times 10 to the power 8, which is assumed to be constant during all the time, even though it leaves the atmosphere of Earth, it goes through all the other gravitational and magnetic fields of all the other planets. Still, we assume that the velocity is straight velocity, 3 times 10 to the power 8. And for one entire year, this light is going to travel into space and go that far. How far? Delta D. Delta D is the distance that we're trying to calculate, which is the distance of 1 light year. If you multiply the velocity and the time, which are converted to meters per second and seconds, you get the delta D, or the measurement of light year, which is equal to 9.45 times 10 to the power 15 meters. Of course, there are some assumptions, there are some rounding numbers or uh, calculation about this number. So this 9.45 is not very accurate, but it's the method of calculating this number is very important. So based on the velocity of light and the time, which is 1 year, we can calculate this distance. So 9.45 times 10 to the power of 13 kilometer is the distance of 1 light year.
Mhm.